All right, Mr. Ahmed here for 9.1. Goal for today is going to be simplifying radicals. And the first thing we're going to talk about is what a radical is. And a radical is pretty much for us just going to be a square root. And in the process of simplifying these square roots, the first thing I want to discuss is what a perfect square is. Okay, and a perfect square is a number where when we take the square root of it, we end up with an integer. It's kind of like more like a whole number in your guys' mind, but it's technically an integer. So for instance, 1 is a perfect square because the square root of 1 is equal to 1. 1 times 1 is 1. We're looking for what number times itself is 1. The next perfect square we're going to talk about is 4. The reason why 4 is a perfect square is because 2 times 2 is 4. Next one's 9. Square root of 9 is 3. And we have 16. Square root of that is 4. So these are perfect squares. Now, how could I memorize these? Well, the way I'm getting it is I'm taking 1 times itself. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. So the next big one's 5 times 5. So that'd be the 25. The square root of 25 is 5. The next biggest one is 36. The square root of 36 is 6. Then we'd have 49. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. And the square root of 100 is 10. 121, the square root of that's 11. And the square root of 144 is equal to 12. And the square root of 169 is equal to 13. Honestly, if we can remember these ones, that would probably be enough. All right, we won't really simplify ones that have bigger factors than 163. So as we start simplifying these, what we're going to look for is we're going to look for perfect square factors. So it may be helpful to write down 1, 4, 9, 16, 25, 36, 49, etc. These are all the perfect squares, okay? So I'm going to just list those off here off to the side without taking the square root of them. So the list of perfect squares is 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and 169. I wrote 163 on accident. Okay, so these are the perfect squares. They are numbers where we take the square root of them and we get an integer. So what we're going to do to simplify our square roots is really we need to have an understanding that a lot of square roots are going to be irrational numbers. So for instance, if I take the square root of 13, that one cannot be simplified. And if we see it as a decimal, it just goes on and on forever and ever and ever with no pattern. Hence irrational. Now, if we were to just round that at 3.6, that's not going to be super accurate if I start multiplying that by something again. So and then if I multiply it again after that, it's even going to be less accurate. So if we can keep it as a radical instead of a rounded decimal, it's going to keep our numbers much more accurate than if we round. So that's kind of the main reason why we simplify these, is so we can have accuracy. So the first thing I want to talk about is the square root of a times b can be rewritten as the square root of a times the square root of b. So I broke that apart. So in a similar manner, if I have two numbers being multiplied inside the square root, 9 times 3, I could rewrite that as the square root of 9 times the square root of 3. Now here, this should ring a bell. That was a perfect square. I can take the square root of 9. I know what that is, but I can't take the square root of 3. That's going to be a decimal. Okay, it's irrational. So I could simplify this down to the square root of 9 being 3 times the square root of 3, which is going to be more accurate than trying to carry a decimal around. And it's easier to work with because it's a smaller number. Hence, simplify. So, in order for us to simplify radicals, we are going to find the perfect square factors that divide evenly into the number under the radical. So find the perfect square that will divide evenly into the number. So I have to find the factors. What times what is that number? We want perfect squares that will divide evenly into the number under the radical. We're then going to rewrite it as the product of the two numbers, and then we're going to give each number its own radical. After we give each number its own radical, we can then simplify the perfect radical. We'll leave the one that isn't in the square root sign, in the radical, okay? So 20 is our first one. So we have to think what goes into 20 that's a perfect square. So we're looking at these perfect square factors. Which one goes into 20? 4 does. 4 times 5. If you do not know that, you're going to have to just start dividing those numbers out and see which one goes even using your calculator, okay? I know 4 times 5 is 20, so I can rewrite this as the square root of 4 times the square root of 5, because 4 times 5 is 20. I broke it apart into the two radicals, okay? Now from here, I can then simplify the square root of 4 to 2, and the square root of 5 does not simplify, so we leave it as the square root of 5. Our next one's 48. So like I said, if you don't know which one of the perfect squares goes into 48, you need to take out your calculator and start checking. Now start with numbers smaller than 48. So I don't want to try and divide 100 into 48 because it's too big. It has to be smaller. Technically it should be smaller than half of it. So 24 is half of this. So I can start with all the numbers less than 24, which the first one that's less than 24 is 16. So I would just take 48 divided by 16. Oh, it's 3. So that's going to work, okay? I just divided it. 48 divided by 16 was 3. So I can rewrite this as the square root of 16 times the square root of 3, okay? Square root of 16 times the square root of 3. We can then take the square root of 16, which is 4, times the square root of 3, and we got it. I'm going to leave this page handy so we can see our perfect squares, okay? So there's our list of perfect squares. Now we're doing 75. So we have to figure out which one goes into 75. 75 cents, I know that's a quarter, so I'm using 25. 25 times 3. Oops, I forgot the square root sign over the 25. Square root of 25 times the square root of 3. We can then take the square root of 25, which is 5, square root 3, and we got it. Make sure after you take the square root, you don't put another square root sign above it. You've already done that. Okay, we figured out 5 times 5 is 25, so we don't need to put another square root sign over it. The next one, 100. Square root of 100, that's a perfect square, that's 10. 18, which one goes into 18? 9 does, so we'll rewrite that. Square root 9 times the square root of 2. Square root of 9 is 3 times the square root of 2, and we have it. And for 19, that one's a tough one. So I know you got to use numbers less than 19. So the first one's 9. 19 divided by 9, that's a decimal. That don't work. 19 divided by 4, that does not work. And then 19 divided by 1 really doesn't help us. 1's not going to change 19. So it's just the square root of 19. That one is already simplified. It cannot go any further. There are no perfect square factors. Our next examples are really going to work the same. We just have a 3 out in front, so we're going to have to multiply by 3. That's okay. So we need to figure out which perfect square factor goes into 32. So I'm going to try 32 divided by 16. See if we get a whole number with 32 divided by 16, and we do. It's 16 times 2. So we have 3 times the square root of 16 times the square root of 2. Now I can take the square root of 16, but I still have the 3. 3 times 4 times the square root of 2. Then we can multiply these two together and get 12 times the square root of 2. This one here is a perfect square. Square root of 16 is 4, so I have negative 2 times 4, which is negative 8. Go ahead and give the next ones a shot. All right, perfect square factor that goes into 8 is 4. So we have 4 times square root 4 times square root 2. 4 times 2 is 8. We broke it apart. We can now take the square root of the perfect square, which is 4. So we have 4 times 2 times the square root of 2, which is 8 times the square root of 2. And the last one, 60. Perfect square factor that goes into 60. Again, we want to start with the bigger numbers. I don't want to start with 4. I want to start bigger. So we're going to start at 36. 60 divide 36, doesn't go in. 60 divide 25, I'm working my way down. Doesn't go in. I got 2.4. Now I try 16. 60 divided 16 doesn't work. 60 divided by 9 doesn't work. 60 divided by 4. There it is, 4 times 15. So we have negative 5 times square root 4 times square root 15. We can take the square root of 4, which is 2, Negative 5 times 2 times the square root of 15. And then we multiply these two numbers together and get negative 10 times the square root of 15. And that's all she wrote. Have a great rest of the day.